For today, we're going to be adding in phase shifts. So for each function, that means we're going to be moving our graph to the left or to the right with our phase shift, the starting points. So recall that when we have a function, we split it up into different pieces so we could recognize what numbers did what to our graph. So remember that A, the absolute value of that, was the amplitude for all sine, cosine, secant, cosecant. The H is what we're going to be doing today. The C is how we found the period. Remember that sine, cosine, secant, and cosecant all have a period of 2 pi normally. And this is how many cycles are in 2 pi. Also recall that tangent and cotangent only have a cycle or a period of pi, not 2 pi. So this was the number of cycles in a period. So we took the normal period, divided that by that cycle. K, this was your vertical shift, or in other words, this was your midline. So once we have the midline, and we have the period, and we have the horizontal shift, and that will come from this one. I'll just write horizontal. All right, so when you're given an equation of 4 sine multiplied to 2x minus pi, the first thing we need to notice is that the 2 is right next to the x. We need to factor that away from the x. We need our c value to be away from the x. So when we factor this out, we have 4 multiplied to the sine. We factored the 2 away from the x, and that leaves us with x minus pi halves. So notice I had to take it away, I had to factor it out from the pi as well. So when I multiply this back in, I would have 2x and minus pi. Now we can write down all the information we need. For example, amplitude, absolute value of 4 is 4. We have the period, and our period is 2 pi divided by the number of cycles, which is 2. So that means our period is pi. We also have a midline out here, which in this case is 0. And we have, this is our phase shift, which means it's going to go to the right pi halves. So now we can put all this information on our graph. I like to start with the midline. So we have a midline of 0. We'll make that a line. There's our midline of 0. We also have an amplitude of 4. So we'll go ahead and put that up here. So that would go up 4, and it would also go down 4 from your midline. We have a starting point of pi halves. So I'm going to go ahead and label my graph here. Let's call this line right here pi, which means this one would be 2 pi. So if I start at pi halves, that's my phase shift. I move to the right pi halves, that would be right in here, half of pi. And then I have a period of pi. So from this point, it goes a distance of pi, which puts us right in the middle here. Now, preferably you'll label these. So we started at this piece, which was pi halves, and we're going to end at this piece, which is 3 pi halves. Now we can draw in our sine function. So remember, our sine function starts on the midline, goes to the top, back to the midline, all the way to the bottom, and then back to the midline. So I like to just put my dots up here. I have this dot, goes all the way to the top, comes back down, all the way to the bottom, comes back up. And there's the graph for this function. All right, here's your next example. We have 2 secant of 2x minus pi halves, and then we're subtracting 1. So again, we want to factor out this 2 away from our x value. So this was going to give us a 2 secant. Factor out that 2, and you're left with x minus pi fourths. And then we subtract 1 from that. So notice if we multiply it back in, we would get 2x minus 2 pi over 4, which is pi halves. So we find our amplitude. Absolute value of 2 is 2. We find our period. For secant, that's 2 pi divided by the number of cycles, which is 2. So our period is pi again. We have a midline of -1. And now we have a phase shift of moving it right pi fourths. So now we can go ahead and put all this information on the graph. We have a midline of -1. We have an amplitude of 2. So that's 2 in each direction from the midline. We have a phase shift of right pi fourths. So let's label our graph again. If we call this pi and 2 pi, leave those in blue. So this one is pi, this one is 2 pi, which means we're going to shift our function to the right a fourth of pi. So a fourth of pi, that's really close to right in here. Our period is pi, which means it's going to be right here. And again, we want to label those parts too. The starting point was pi fourths, and the ending point was 5 pi fourths. Or in other words, I'm getting that by taking my pi fourths and adding my period, and that tells me 5 pi fourths, which is where my first cycle will end and my second cycle will start. All right, now we're graphing the secant function. And remember the secant function, it looks like the cosine function being flipped where these zeros occurred. So we would take these pieces, and I would take this function, I'd flip it out, and I would flip this part out, and this U shape would flip out. Right, so these two lines and this line are your secant function. So this one is cosine, and these parts out here are secant. So as we look at our function, so I'm going to lightly draw in the cosine function, which would look like this, right? So that means we're going to have this portion of it's going to be flipped out this way. Same with this portion. And then this inside piece is now flipped out this way. Remember, we do have asymptotes on here, so I'll put those in red. They go right down through here where they cross those pieces. And it looks really like a lot of lines because we've drawn in the asymptotes for these two pieces coming through here.